So in today's podcast, we're going to talk about the Earth, the general mass of Earth, as you can see, visually described for everybody here. No, I'll change that. Sorry, it's just me taking the mickey as always. Choose my background. Da, 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 da. There we go.
All meaning from the International Space Station.
Yeah.
Well, I'm just happy there's good editing.
Absolutely. Don't worry, that'll appear at the start. What we're going to do on this one, so we've just done a quick feedback one, which is great. All three of you steer this however you want, and us three will ask the questions.
Right, great.
Okay.
Hello, everybody, and welcome back to the E5 podcast. My name is Paul Meenan. Thank you for joining and listening or watching or whatever medium you're on. I am joined by my regular tag team partners and brothers. Please introduce yourself.
Hello, I'm JW. And it's Dave Watts here, Sparky Ninja.
Thank you for joining me as always, guys. And we are now joined again by some good friends of ours from industry, the chaps from Earthing Services with one additional member. Gents, please introduce yourself.
Right, good day all. My name is John Mayer, Technical Director of Earthing Services, UK Limited.
John from Earthing Services.
And I'm Todd Sorolla from SAE.
It can be done. Welcome back, sir. I remember. It can be done. So welcome back, chaps. Now,
well done.
We good memory, you see. We've done quite a few podcasts with you now. We've just done a feedback one with the chaps. And what we thought we'd do is just turn this over to you, because one of the questions we did off recording was talk about what the future holds for earthing. And we talk about technology as widgets and gadgets in lights and sockets and Internet of Things and all the things within a building. And we do not talk about any advancements in the ground. And you guys with the Conduidus is the major upgrade in earthing technology, earthing engineering. But we want more because we like more. So I'm going to turn this over to you chaps, and I'm going to ask Sean first. Sean, what do you got for us? What are you doing? What are you working on?
Well, we listened. That's what we start with. We find out, we like to hear problems, because with someone's problem, we can then start by developing a solution.
So hang on, you're earthing therapists as well?
Absolutely.
Yeah, we've got couches. Yeah, we have a whole counselling department. So yeah, one of the pieces of feedback that we would occasionally receive from industry was that the length of interconnection conductor on a Conduidus was too long, too short. Could it be 50 mil? The AWG conversion was 13 mil as opposed to 16 mil. Can it be 16 mil? Can it be 30 meters? Can it be 31.5 meters long? Can we have tape on it attached instead of the cable? All of these different variants, and of course, people had those different requirements, because so often any given site is going to have its own demands, its own constraints, its own specification document from a consultant who said, thou shalt install earthing conductors to this side of this type. So we recognised that the Conduidus in its original form, which was a precast plate with a precast in interconnection conductor, wasn't going to be always suitable. But that didn't mean that the technology was in any way insufficient. It meant that we just had to respond to adapt it to make it more flexible on site. So I'm now going to throw over to Todd so he can show you what we did.
Okay. So let's start with the one from the beginning, which Sean just described, and I'll just put it up briefly on the screen. This is the Conduidus Pro. This is the original product, and as you can see, we had a wire cast right into the disc, and the length and wire gauge was predetermined. And as Sean said, that doesn't always work because people want quite a variety of different wire gauges and lengths. So that's where we started from. And bear with me, I'll move to the next version. And this this is the Conduidus Flex, which I hope you can see. And what you'll notice is that there is no wire connected, but there is a slot where you can connect it. And so with this change, especially for people in other parts of the world that have different wire gauges and different requirements than we have in North America, we're able to deal with that now, because the customer can put their own connector on the end of the wire and then tie it onto the Conduidus Flex.
Yeah.
And
So
what I'll show you next is that this is a one slot disc, but we have also got a few other options for you there. So
yeah,
hold on a
great.
second.
Whilst Todd's doing that, it's worth pointing out that, you know, the idea with this is that you would lug whichever cable you wished to use for your application, and then that will go straight onto the plate. And as we'll talk about in a little while, that open way can then be sealed over. Now, at the minute, the discs are coming in with either an M6 stud or an M12 stud.
Just ask my question.
Okay, preempted. Yeah, so with that, it means that you aren't having to interfere with the plate, or you're not going to have to drill into it or anything. It's sat there waiting with the given number of ways
Around the pad mount, and then the third one is directly connected into the transformer ground bus.
It's probably worth mentioning that on the original Conduidus, the plate itself was tested to, was it 47 kA, Todd, if memory serves me right?
Yeah, and I think there's been more work done, and we're up over something like 55,000 amps now. So
what we're saying there, whereas the previous one, we were limited to the size of cable that was connected to that plate. But now, with this new Flex, we can size any conductor to suit the HV needs predominantly. So, 50 per 6, you're looking at, what was that, around about 50 kA? So it has no limits. So whatever the system requirements are on a HV side, I know it's not LV now, but we now can more or less fit these flexi discs to suit any HV arrangement.
What type of sealing is used? Is it just part being with concrete, or what kind of sealing is required for that?
Well, there's a couple of methods. The method that comes supplied with the disc is a sealant kit, which works very similar to if anyone's used sort of cable jointing kits.
Like a gel kind of form, is it?
Well, it's a burst bag in the same way that it's a two-part bag that you will split in the middle.
Yeah, the resin fill.
That kind of thing, but it's a conductive sealant. Again, as you'll be seeing.
Oh, you want to put one of them in your joints, would you?
You really wouldn't want to put one of those in your joints, because you're never going to break through it again. It forms a highly impermeable surround. It will so therefore protect it from any deterioration that way. It obviously increases the size of the conductor, protects the point of connection, but moreover, because it's all conductive, it means that it's actually also helping to
improves it, maybe.
Exactly that, yeah. So it increased the source of the area of connection. But as you'll see with the burst bag video that you're probably seeing now, or you've already just seen. Alternatively, if you're doing a combined system, so it's not just a Conduidus Flex being installed. If you're then installing this with Conductive or Flow or Form or any of the other mediums that we have, that would infill in the same way. Whilst we would always recommend paying direct attention to that, the seal you've just made yourself with that burst bag. If it were being installed in a Conductive type system, then the Conductive would fill into that gap and
remove it, is it?
No, it's not exactly that. So, and once again, you've increased the whole area of both connection between the various elements, but also discharge.
So what you've basically done is you've effectively given us far more flexibility for the application. And just because I'm going to put John in check here, not just HV applications. This is any application.
Absolutely.
Yeah. So you've increased the flexibility of connection, and you've also taken steps to, once it's all connected, to effectively ensure that that area where the connection is made, the impedance is assured and is protected from corrosion. So for those who are listening to this, this is the time you go, I need to be watching this on YouTube. Yeah. You can see the images in the video and stuff. So anyway,
again, I think as John was alluding to, though, you can actually increase the gauge of the cable connecting it for higher levels of energy that the disc is actually, so the disc as packaged now technically has a higher potential fault energy tolerance than the cable connected to it.
Yes. So, and one thing we might want to ask our listeners, if anybody wants to put 50,000 amps through an earth rod, please feel free to see how long that one lasts.
Please video it for us.
Yeah, and video it for it. However, I take no responsibility for you doing stupid things.
No.
When you've managed to kind of pour the earth rod back into some sort of bucket, we'd like to see that. It's no, but this is it. This is one of the points of difference with the way that SAE develops their products, and we work with the way we all work together. But I'm extending that to the way we work with people like yourselves. It starts with listening. It starts with that point of communication, because we can develop problems all day. Yeah, but if we're doing that in isolation, ultimately we might be great at earthing, but if we're not going out doing installations, multiple times a week, then it's quite easy for us to solve problems that aren't there and not solve problems that are. So this disc is a product of people adopting the technology and then saying, right, let's let you know how we can go about improving this. So it comes in different versions, as I think Todd's already demonstrated. That's a three-way. We've got a four-way, which is more like a north, south, east, west. So you've got that. There's the single open ways. And also, it's not been said yet that these products, there we go, that's the four-way.
See, again,
M6 studs.
I think about like the furze welding that Richard had to do to create his farm. With something like that, you can literally just grid connect them.
Yep. You remove any of the C crimps or anything, you just bolt.
Yeah.
Well, even then, I know that some sites don't like bolts. And again, I can understand why, even if they're kind of looking past the fact that that bolt is now actually enhanced with this conductive surround. You could spot weld onto that. If that's a case of no, the spec calls for weld, then you can still do that with this method. You've got to be a bit careful, more careful with it than you would just on a bare metal connection, but it can be done. Again, just to use that recurrent phrase. And also, and it hasn't been said, but these are going to be, cheaper than the Pro versions. Whilst price points will vary, subject to volume and all that stuff that I'm obliged to say commercially, the reality for anyone using them is this will be cheaper because we aren't going through the process of picking the conductor that may or may not be suitable for your application. So, we've taken that out. It's no longer being raw materials that no one's making profit on around the world. It is just, right, that's the product, you can use it. But worth pointing out that that's not the end of the evolution of the Conduidus. And indeed, we're not just still sat around waiting for anyone to get on, because Todd's actually already got another variant on it. So, Todd, do you want to have a look at the Elite one?
The Elite. I'm already liking the sound of it.
Next, we have Elite.
This sounds lofty.
Yeah, I think we're about to be an exalted company. Here we go.
So, the Elite one here, you'll notice that the wire that's connected to it is the Condu wire, which is a conductive jacketed wire. So now not only is the main electrode protected against corrosion, but so is the conductor that you connect to it. So
hang on a minute, a Condu wire.
Yeah. Condu wire, yeah. So I'll show you some more samples of that in a minute. But so this is one generation change, and we're going to share another one with you a little later.
So Yeah, so whilst Todd's getting that, that is a combination technology of the Condu disc with the Condu wire. We haven't talked about this previously. This is something that is, again, is red hot. It's really literally just being released now, but it can be supplied as a separate product on its own.
Sorry, Sean. So this is obviously proprietary technology. This is SAE and Earthing Services IP. So this is your baby. You own it. Okay, right. Okay, so we won't be getting Condu wire from anybody else. Okay, that's fine. So in our earlier podcast, we talked about earthing, the earthing technology of SAE being a way of plugging into Mother Earth, or the black hole of Earth connections on the planet, whatever you want to call it. So Condu wire, talk to us more. You've got more stuff. I'm slightly stunned here. So tell me more.
Yeah. So the Condu wire, and I don't know how well you see that, but you can see it's coiled, right? So the real success here, I guess, is that we've come up with a way to put a very flexible jacket, very similar to what everyone would think of as an insulated material, except ours conducts. So why we're doing this is because, we had a client say to us a long time ago, well, I love this disc because it'll protect the metal against corrosion, but what about the wire? And of course, we've been working on this for years. So the reality is there are a lot of parts of the world. I may have mentioned this on a prior discussion with you, but when I was in the Middle East, I found out about a client who had to use vertical electrodes and interconnect them all with insulated wire. And I said, well, why on earth would you do that? And they said, well, because if we don't, we can have complete corrosion of the cable in under 6 months. So that's where the idea for this was born, because I thought, well, geez, I don't see why we couldn't develop a polymer that was conductive. And then when people are in these situations, they could in fact protect the metal and still have the use of the large horizontal component of the electrode. And in the case of the situation in the Middle East, these vertical electrodes were, hundreds of meters apart. So imagine the electrode, using this material where you wouldn't use an insulating conductor just because you're worried about the metal corroding. You'd have this. So there are huge applications for something like this, because everybody's aware now that they're burying the metal. Traditionally, grounding's just done with bare metal. And of course, the corrosion of the metal is a function of the soil chemistry, but it's also a function of the proximity to stray DC from cathodic protection systems. It's a huge, huge problem. Well, sure, we protect the buried infrastructure with CP, but the stray DC starts to consume all the bare metal in the earth. So you can imagine in joint use corridors where you've got pipelines and power lines, which is quite prevalent, in many parts of the world, where you have one system destroying the other. And this is one of the major steps to taking care of that. Now, traditionally, our conductive concrete would go over the bare metal and form the electrode, and that also stops or dramatically slows down the corrosion of the metal. But this is another step beyond that.
Well, it's also comes down to that word we've used previously. It's flexibility. Some sites don't have. It's not held outright. It's not a freehold. It's a leasehold. Yeah. It's leased land. So if you're talking about installing a system which is still going to be exposed to discharging AC or DC, then it's going to result in deterioration of bare metal. However, and also you wouldn't want to install concrete on that, because whilst it would do the job, if you've got to return the land as was 40 years from now, if you're thinking about something like a solar farm or a 25-year lease, then you're going to have a real problem getting all that conducrete back out of the ground. But if you then use something like, the Condu wire, it's both protected, it's so it's not got those same threats, electricity, but you also don't have the headache of getting it back out.
It's also fair to say then that because of this jacket, it's increasing the overall cross-sectional area. Is that right, Todd?
Yeah, the interesting thing is, while we're in development on this type of material, obviously the metal is far more conductive than the jacket that goes on it. So I was curious to see the impact when we started doing traditional resistance testing. And John's absolutely right. When we did head-to-head testing of a bare copper system versus the jacketed one, because of its increased conductive surface area, was actually outperforming the bare. And I wasn't 100% certain of that when we started working on this, but it turns out, if you've got a relatively conductive soil that you're just introducing with the metal, you're actually using the earth itself as fundamentally your electrodes. So what this turns out to be as a jacket is just a slight increase in surface area. Or if you want to think about it a slightly different way, it's the first layer, the interface layer between the metal and the surrounding soil.
Can I just jump in there? Sorry. So forgive me. This has blown me away. This jacket enhances the electrical conductivity because it adds to that CSA a little bit. It's an option instead of the concrete, but it also so it allows that conductivity of the earth connection to the soil. But what it's doing is protecting against effectively chemical attacks and corrosive elements in the ground. So
that's right.
Okay. That was because obviously if I wanted to put in the UK, if I put an insulation tester on the core and the sheath, in theory, that should be really, really low, which would be great. But this is when we're burying the ground. It's if there's any nasty chemicals that could easily chew the copper, it would act as an insulator. So in theory, I could have a Conduidus with this Conduflex, or if I wanted to be a complete and utter tart, I could have a Conduflex and just go the whole lot. There's a lot of flexibility with this, and there's a pun there, by the way. Do you like that? I just realised that as I said it. It was good, Dave.
And the Condu wire definitely improves the earthing effectiveness to the bare wire.
It does. It is. If you look at it head on, I don't know how well you can see this, but there is an increase in the surface area by having the jacket around it. And when we did the testing, we saw that we had, improvement over just bare wire. But I think plus
the protection as well.
Yeah, I think the really interesting thing is that when we first started, years and years ago in this business, over 30 now, there was not as much clarity from the client base on the impact corrosion was having on their buried metallic systems. And over time, that's changed. And I think this is, because the clients are better educated on this issue, we're starting to have, a lot of people interested in this. I mean, I had the first time I showed this to a major U.S. utility, and we had 4 or 5 items in the presentation, and the last thing I showed was something like what you're seeing here, just an end view of this jacketed conductor. Well, the guy was so interested, and there's a reason, right? Because he knows he's got massive corrosion problems in his network.
Did he call you a wizard? Did he call you some sort of witch doctor and say, what is this magic?
I prefer shaman, but
I never thought in my career I'd be talking about a cable that's sheathed, that is conductive.
Sheathed to conduct.
Hello. Yeah, by the way, UK first.
I will say the first time I met Todd, went over to Barry and went into Todd's secret laboratory. Well, what a revelation. We had this tubular 100 mm diameter tube of concrete, and I picked up one end and I could literally flex it. And another time we had a piece of what appeared to be rubber, and it was so flexible on a strip of a copper strip. Yes, he is a wizard.
Mr. Ward, what do you think about all this magic?
Well, that wire, that would be ideal for DNOs to use at the service joints, because you know where they currently join it and stick that electrode next to it, which is going to rot away in 2 minutes. Put some of that in instead. That's a perfect application for that.
The alleged electrode, yes.
Well, yes, we all know about that. It's a separate issue there, but that would be an ideal situation there, because they could put just the length of that in, say, like a couple of meters of that in the floor, in the ground. It's not going to corrode. It's going to do the job forever, and it's going to be just as easy to connect into what they're using now. So, yes.
Well, you said that, John. I didn't. It is worth saying when it comes to corrosion and power networks. If any of you are listening, we're not always honest about it, are we? Whether we're talking about direct buried steel structures or anything else, if you've got something that's carrying power, then there's going to be corrosion somewhere. For those of you who, if you are listening, there is a way to solve it. We can help. We've helped others. Because this is, and none of that is anything other than exactly what we've talked about. Instead of trying to fight a losing battle by putting an insulating coating on it that's going to get scratched during installation or damaged even just in transporting the thing to the work site, if you actually encase it in something which will protect it from deterioration and actually increase your earthing, then guess what? You're in a better situation. Because, and if we're talking about something like direct buried steel where the actual foundation is being used as something like Conductive, then it's doing more than one job. It's protecting from corrosion, it's providing a structural foundation, and it's increasing its service life. And that is, I've just talked about HV power network application, that's obviously transmission. But yeah, like John was saying, distribution, it all starts with conversations and just thinking that these things that we might have accepted as inevitable, just the cost of business or the risks of business, the tolerable risks of business we've all lived with forever, we can do better. And, it needn't be particularly much more expensive. In fact, over time, of course, it will always be cheaper.
Okay, so I'm slightly blown away by that, because that's now challenging everything I know and think about in regards to cabling. I'm sure there will be questions on, as a cable, as an entity, what standards are we making it to? Are we writing a standard for this cabling product? How does that all work? There'll be, people, the nerds, that's us, will ask questions like, cable standard, product standards, but we can cover that. This is your IP at the moment, so this is a journey that you're on. But one thing this tells me straight away is the DNOs, the networks, the transmission operators, they always have their approved product registers. And this is a challenge to anyone who works for any DNO. Go and ask a question, because I've asked this of my local DNO, and I've told them I'm paying my DNO to improve my infrastructure. And I've told them I want discs, and they go, our approved product. I'm like, no, I'm telling you I want disc. Go away and improve your mindsets. Because if I'm telling you I want a disc and I'm paying for it, I want a disc. But just generally across DNO, anyone who's listening from a network, I know that E&A are quite fussy about products and approvals. This to me says that we need an earthing engineering, a national event to talk about this sort of stuff with these partners or, locally or whatever. But I think there's definitely some hearts and minds that need to be opened up as to the realms of possibilities. And why? Because all of this, while you've been talking, all I'm thinking is whole life cost return is phenomenal.
Yeah. It's, all these things are interrelated. And as an example, as Sean was mentioning, the direct buried steel that most of the utilities are using now, rather than the traditional lattice towers. But the direct buried structures, the most significant concern, generally, aside from the crews and whether they want to climb steel structures and what have you, but putting that aside, the fundamental concern is, well, we're concerned about the corrosion at ground line and slightly below. I mean, you know, I guess technically you can have corrosion down to about 8 feet, where you no longer have sufficient oxygen in most circumstances to have a corrosion problem. But you know, that's where you know, we've actually been doing a lot of work. We're now standardized at utilities in North America, but the next hurdle was, how do you get a bulk sack of conductive concrete into a hole when you know, right when you need it? And the answer to that is you use a volumetric mixer. And these devices allow you to individually batch control. So all the conductive concrete is loaded into the system, and then all you have to do is control the amount of water, and out it comes on a screw system where you're inline mixing it, and it goes in. So you can backfill a pole in you know, roughly 5 or 6 minutes, and you don't waste any material because you're individually batching. Well, once you do that, you have a tremendously good ground, right? You set the pole, and we offer actually wedges to allow you to fix the pole in place while the conductive concrete cures. But then you also solve the corrosion of the direct buried metal. So it's a very, very significant improvement, because you have the pole in place and the corrosion issues dealt with. And when we did this in the western part of the US, Southwest, they were astounded. They had about an ohm and a half at one structure. So this is something else, and I'm glad Paul hit on, you know, the discussion about these things. The most significant barrier to innovation and change is just the protocols that you're forced to go through with these large corporations. I mean, they can take advantage of these things very quickly if they want to. But if they choose to go the normal route, I refer to the whole process as snakes and ladders, because you go all the way up and you get near the end, and then you fall back to the beginning because somebody moved on and got transferred. But I think it's really important to bring these things forward. We're all about improvement and saving huge amounts of money over time for the utilities, but they have to take advantage of what's there and streamline the processes for driving this change through their standards process, or they waste literally years sometimes. Everybody says, yeah, that's a good idea, but it still takes 3 years to get it through the process. I mean, it's really quite difficult to understand when you're in the business of innovating, but this is just the way it seems to be. And I'm not sure what it's like for you in the UK, but in North America, it's unfortunately been our experience in many circumstances.
So it takes us probably 5-10 years in the UK. Innovation is proportionately linked to risk appetite. And this, to use a big word for corporations, because I work for one, I'm a big fan of innovation, and I have a healthy risk appetite for it, because the proof's in the pudding. If you know, you know, and we should be support anything to me that's a safety improvement or a betterment. I'm willing to take that risk.
Yeah. Well, can I just jump in there? Because, you know, Todd talked about saving money, and you've talked about safety improvements. So maybe we have a look at saving some lives. Not only, we've obviously talked about that through the methods of creating permanent or long-term earthing solutions, but maybe we could have a look at some of the temporary personnel type stuff, Todd.
Sure. Yeah. Let me grab my neck.
You've got more?
Oh yeah. There's more.
I mean,
You want to see his laboratory
from the Conduiflex.
So, you know, with the Outrigger stabilizer pads that people use now are either wood or polymer plastic, non-conductive.
But Chad, just let me jump in there. So if we're thinking about transmission trucks, so the stuff that's going out on transmission lines for new installs or remedial works, testing, whatever.
Replacing overhead lines.
Yeah, replacing overhead lines. They have stabilizer pads. They're outrigger stabilizers that come out from the sides of the trucks and go onto the ground.
On the ground, yeah.
Yes, Todd was just saying there, normally you'll find them made of a polymer or wood. So basically, they're insulators. Over to you, Todd.
Yeah, so this is a cast aluminum outrigger pad, which I can assure you is very difficult to destroy. We haven't managed to do it yet. But, you know, one of the keys in doing the personnel safety change, when we first got introduced to these problems, all we saw was wooden pads. And I'm looking at the guy saying, well, that's not going to conduct. So we did the measurements with clamp-on testing device. And, you know, the best one we saw with the pads, 4 of them down, was 950 ohms. Well, that's not going to trip a circuit. So usually you need dramatically lower. You need something in the order of, 25 ohms, and depending on line voltage, maybe up to size 50. Well, so the best way to show people the performance improvement is to do the measurement 950 or even 1500, which the clamp-on is saying is an open circuit, and then you replace the same pads with these aluminum ones, and you're suddenly down to 40 ohms or something like that, depending on the surface soil resistivity. But it's such a simple change, right? So we developed this, and we're working on bringing it to market now. But we worked in partnership with one of the major U.S. utilities on this because they recognized they had an issue. And so what goes hand in hand with this outrigger pad is another device. They said to us, well, we have the trucks that will turn the augers in. We want you to develop an electrode that we can use our automation to put in. So we also have a stainless steel grounding screw that they can also put in. So between the 4 outrigger pads and 1 or 2 of these screws, you have much better temporary protective grounding. And of course, most of the time in construction, you've got multiple trucks tied together. And so, again, these types of solutions are available, but you have to go through the standardization process with them.
Yeah.
It's if you can't trip that circuit, people get badly injured or worse. And what's astounding to me is how we've gone for so many years with non-conducting stabilizer pads.
Probably because they may not have existed in that context. Can I be honest with you, and please forgive me for lowering the tone, but I have to do a joke here. When I saw that, I thought that was a baking tray. And when you said that nobody can destroy it, I thought, give it to my missus, let her make some cake. She'll have that destroyed. She'll have it destroyed.
Well, I was going to say, it's like a big waffle iron.
Yeah, it does look like a great waffle iron. So the objective here is to rapidly reduce fault clearance times. Is that correct?
That's right, and to allow for circuits to trip, especially when you have in a transmission corridor, there's not always an overhead shield wire. So what people do is they put temporary ground rod in, maybe that far or something.
Yeah,
see it all the time, and then they tie to the nearest structure. And many times, if they're older structures, the grounding corroded away or was removed by a thief, 15 years before.
Yeah, you can see that in the UK
security
as well.
That there's yeah, and these crews think they're safe. That's the most disturbing part. They think they're safe, and in many circumstances they're not.
Can I suggest, Todd, you watch on YouTube a video called Pylon Men, and you'll realise that most of the men who work on them are suicidal lunatics.
Yeah.
Well, then
they are not. I'll do. These guys are not scared of electricity. Electricity is scared of them.
Okay.
That's sort of people who work on these network stuff. Have no fear. Anyway,
I mean, technically, anybody who works with cranes or works, with uses cranes on construction sites or anywhere else who has a risk of clashing with an overhead line
That's true. Yeah. Yeah.
would
That's the
benefit
other
from that
main-
good reference of an earth to clear that fault.
Yeah.
I've raised an even bigger issue for the UK. In the UK, where we have structures that may be part of an earthing or a foundation earthing system, when the section of I-beam has failed or is failing, they will put something called concrete boots on, where they effectively just shutter around the steelwork, put concrete surround, let it dry, and then remove it. And that then extends the life of that structure or that I-beam, because the section has failed. But if you're using that for earthing, you've lost your earthing.
Yeah, absolutely.
So, and that happens a lot in the UK, a lot, and it happens a lot on railways as well, a lot. You can see it on railway platforms a lot. They're called concrete boots, and it's just to extend the life of the structures. It's a known practice, it's an accepted practice, but maybe are we thinking maybe about the earthing as well as when we're doing that? Probably not. We're probably just thinking about section loss of the structure, but we need to think about that. Right.
But we can solve that problem in advance. That's the thing. We could have solved it day one. Again, some of these technologies are only coming online now, but, don't accept how it's always been is the big kind of headline here. Even if that means challenging us to come up with something different or finding a new method.
So I didn't expect all these toys. Have you got anything else to show us as far as innovations? Or have you got a queue of people after Todd waiting to go, oh, I got this, I got that, I got that?
Let's start selling tickets to his workplace.
Todd could do this all day.
I do have something else here.
Go for it.
That I'll show you, but there are a few things I'm not talking about today, which maybe if you invite me back, I'll be in a position.
Well, you've just invited yourself back, haven't you, really? But yeah, come back.
So this is the next generation of the conductive plates, which I mentioned a little bit earlier. But this is a thermoplastic surround, and so it's lower permeability than the one that's currently being utilized on the various versions of the disc. And I'll show you in cross section, so you see. But the reason we're calling it the Condu plate is because we're no longer going to be just doing circular disc type electrodes. And, this might be a moment to talk about the EV world, because we recognize that if we're going to do millions of them, if we're going to do millions of charging stations, then we have to have technology that's more aggressively priced, but still delivers the results that we need. So that's a thermoplastic. And the reason we're pursuing this, aside from that improved permeability, is also so we can further automate the process for delivering this product. So we're working right now to develop the appropriate chemistry so we can actually use injection molding to manufacture this type of product. So we can scale it up, reduce the price, and everybody's happy, because
that's half that is half the problem, is that you can come up with the innovation, but then you've actually got to come up with the manufacturing and the assembly. You can easily create the design, but then you've got to have the assembly to manufacture for quite a large demand.
Right. And, I was reading an article the other day, and I'm not certain of any of this. I don't know how you guys feel, but they're talking about in the United States up to 8 million charging stations in the next 15 years, I believe. And you guys are doing something similar. And
yeah, we need to get off the Russian oil, which is fairly evident now. They could have sent that memo a few years ago.
Yeah.
But I think I don't know. I'm not talking about the politics of it, but the whole EV rollout and I love the fact that there was a webinar in England where hundreds of people were asking, can the grid cope? And of course, the national grid can cope because it's a transmission operator. But the local networks have to do a dynamic assessment of the loads for each transformer they've got. Mm-hmm. It's slightly worrying, but the EV rollout, I think, is a good thing. It's a technology thing. We have to keep up with the future. I'm putting an EV on my house, so I've no problem with that. I do have problems with the technology that's being used to mitigate earthing, and you don't need rods, blah, blah, blah. No, what you need is a brain to understand that a hazard you're introducing. That's what you need first. And good earthing and good coordination is far better than a device that can easily fry when there's an overvoltage from a frequency spike, because the network is unstable. So, yeah, engineering earthing is a lot better for me.
What's the installation strategy with the plate? Is it similar to the disc?
Yeah, I mean, I guess what we're doing is we're looking at different options here. Like as an example, you know, if we get the structure of the, you know, the way the whole thing is founded and set up, we could simply use a batch mixing device like we've been talking about, and use Conductive as the way to found the structure, right? And then in some cases they're going to use bollards around. So instead of one small plate,
a number of them,
you could have 4 bollards, right? So,
I've got a question.
Yeah,
because we are currently doing Type 2 connection chargers and various 22 kilowatt chargers and all the rest of it. But there is this. I was talking to a chap last night who's doing an experiment in London, and they're putting in 3 charging plates. You know, the induction plates. To drive vehicles on. And I was asked whether or not I would be willing to do one on one of my railway stations. And my initial thought was, if I stand over it, does my phone just start charging straight away? Because I've got one of the contactless phones. Will we get lots of teenagers just laying their phones on the ground charging? You know, come on, nobody's ever discussed it. Let's discuss the things that people aren't discussing. How would that work with? Just how would that work, actually? Well, that's probably a separate podcast. We probably need to take that into a separate podcast, actually. But
yeah, we are looking at that. It's early for us, so I don't have a whole bunch to say, but I think there may be conductive materials that we've obviously already got that might be helpful in those applications. But we have more homework to do on how the systems work.
Yeah. I know there's a big vision, isn't it, that they have motorways where as you drive, you're charging. Yeah, that's one of the big visions. Insane.
Yeah, but you know, it's like if you go back to the charging stations as we understand them now. I guess my point here was that we were going to look for dual purposing some of the pieces that are inherent in any of their designs, as well as offering, you know, something like that to do the grounding. But if there are other parts or pieces that are in every structure, and we can either found them or dual purpose the bollards or what have you, these just make it easier for the people installing them and the people that are having them built to put better grounding in without adding very much cost, right? Like one thing you learn in business is if the multiplier is 1 million, your platform has to be very aggressively priced, or everyone goes, that's fantastic, but we're going to use a ground rod, or we're going to, as you pointed out earlier, Paul, we're going to use a trip device that probably won't trip and that sort of stuff. You know, we just want to be able to use techniques here that will make it so compelling and so cost effective that they do the right thing instead of something else.
Fair enough. Right, you haven't got anything more, have you? I think we'll wind this one up. I'm just blown away by the Condu.
Let me go look in the closet.
Don't worry. You've got more. You'll come back. My brain has just melted on the Conduflex stuff. That's blown me away. So I'm going to ask Dave or John to give me some feedback. So we'll take back the reins now. Mr. Watts.
Yeah, mate. Oh, yeah. Well, great.
I feel like I've been on a class, on a training course.
Yeah, I need to. I mean, yeah. Where do I start? Okay, I need. I'm going to have to do some. Please send us some information on the Condu wire and stuff. After our first webinars podcast, what these are podcasts, I said, okay, you know, like with events and stuff, we can't use the Conductive, but the disc is just as good. And we had a previous podcast where we said our experiences with that. But add to that the Elite, where you have the wire, which also achieves a good level of earthing.
Yeah.
I think that's my new favorite for events and temporaries. Really, it's, you know, I can't use Conductive. I can't make something that's going to be permanent. If I can add a connection cabling that also improves the earthing, then that's the new preference.
Dave, could you imagine just this load of wire everywhere and wrapping your generators in it and doing all sorts of stuff? So it's all low impedance. It's all good fun. I'll tell you now, the 7009 boys are just going to have fun with it. They're just going to have fun with it.
But it's good stuff. Yeah, so that's really really interesting, and I think
and it's a new way of getting an apprentice to hold a cable and putting an insulation resistance tester on and say, "Don't worry, it's insulated," and push the button and go, "Oh, what is the cable?" How many pranks are coming down the line for thousands of apprentices over the years? So yeah.
How do you think these are invented in the first place? It's just Todd. It's just pulling pranks all the time. It's just all he does.
We're going to get very serious now, Mr. Ward. Give us your thoughts.
Yeah, I mean that wire particularly, I can see a lot of applications for that because it solves all those problems about corrosion. And I've seen earth rods where they've corroded away in the ground, literally to nothing, and that's just like it's been in there for 10 years and there's nothing left. It's just a crunchy, corroded pile of junk. And obviously the wires do the same. So I see a lot of applications for that. And certainly that plate, if that's going to be injection molded, presumably that would reduce its cost considerably compared to the other types of things there. So yeah, definitely. And as you said there with the charging stations, all the commercial ones in the UK will have posts or bollards around them as required, so people don't basically run their car into it and destroy the place. So again, that's already a given that's going to exist. So again, it's an ideal option to use these products there and basically just do what you're doing, but make it a lot better for minimal extra costs. So, ideal.
Yeah, my brain's melted. I'm blown away. Yeah, I think there's a lot of options here. Do you know one word that comes to mind? Versatility. The level of options now on how you engineer your earthing are now going through the roof. And so the earth rod, yes, there'll always be someone putting a bit of copper-plated steel in somewhere, but the versatility, the options, the life cycle, the configuration, the soil conditions, the ground conditions, the temporary or permanent conditions, we now have answers for, which is mind-blowing. So, chaps, I am going to thank you, Todd of SAE, Sean and John of Earthing Services. I'm going to thank you very much for joining us. You've already invited yourself back once you've got more secrets to tell the world. So you're more than welcome to come and hijack this podcast again. John and Dave, as always, thank you. I'm going to go get some headache pills now because it's just done my brain in completely. And for everybody watching, thank you very much for watching. Thank you very much for listening. And until the next one, take care of yourself and each other. Bye-bye.
Bye-bye.